Well, it's a time to, I would like to go ahead and start. First, I'd like to welcome everybody for the Stride webinar. I don't know, if you cannot hear me, you can type the message to the chat box so we know. You can use the your computer audio or use phone. So my name is Hugo Zhou. I'm a professor of transportation engineering from Department of Civil Engineering of Auburn University. So for this webinar, I'd like to talk about a study we just finished. This is a one-year study funded by Stride. So on the impact of driver characteristics on the headway selection and the free flow speed at the walk zone by using naturalistic driving study data. So from this webinar, you probably will learn a little bit about what is the NDS study data and how to estimate walk zone capacity, some computer simulation tools, and also how the driver characteristics impact their decision makings at the walk zone. So the Auburn University is part of the Stride. This is a Southeastern Transportation Research Center, the regional UTC, Region 4 UTC. There will be 10 university in the Region 4. So, and for my, this is outline for my presentation. I'm going to give an introduction first. What is a research problem, and then objectives and the scope, then methodology. Finally, that's the results and discussing some next step, and also limitations next step. So for the introduction, as we know, the national highway system grows older. The increased number of walk zones has been presented to address growing needs for maintenance and construction. Walk zone occurred on roadway that often cause congestion. So this morning, I actually pull out a map from Alabama Algo map to show how many walk zones on the Alabama freeway. So there are a lot of things going on. So how to help better plan walk zone, traffic control, how to use the simulation tool to estimate the potential delays caused by walk zone. I think it's this is very important issues for the state agency. So to better understand those construction work on the freeway and try to minimize delay issues, there have been a lot of planning simulation tools available for estimate, predict walk zone capacity. For example, highway capacity manual has a walk zone capacity model. Other simulation tools include the coursing and the vising. Those are the tools for the walk zone planning and develop a plan for the traffic control. So for walk zone capacity analysis, there are two different methods. One is a non-parametric method and a parametric method. For the non-parametric method you need extensive historical traffic data to provide a reliable prediction. For the parametric method, the highway capacity manual method is a very typical one. Is a macroscope model which cannot account for various walk zone configuration, or only a few capacity estimation methods were derived from not many from the speed and flow relationship. So a lot of past study on the walk zone using the simulation tool. As we know, the vising is one. So the simulation tool is trying to replicate the real world traffic condition. This is all micro simulation model needed to be calibrated for local condition. But what I heard is I talked to one of my friend at the conference about what is the headway they use for the walk zone, for the different driver type, and what I I was told is they used some very old survey data many years ago in California. Basically, ask people what kind of the headway they may use select on the freeway at the walk zone. So there's very few past study actually considered the impact of driver characteristics on the headway selection in the walk zone. So, and we also studied a lot of the walk zone NDS study, and most of them focus on the safety issues, like critical event, near crash event, where this happen. So very few. This probably first one we tried to use the NDS data to study the driver's headway selection at the walk zone. So NDS data we collect include, you can find all the driver information, vehicle information, and their speed, deceleration, acceleration rate, and also trip data include the multiple videos, forward view videos, and headway data can be found from the forward radar data to find how, what's the time headways from the driving vehicle to the front vehicle, and also the speed data for all the vehicle for the. So the conclusion from our literature review show that none of the past walk zone study consider actually driver characteristics and their car following behavior. And NDS data can provide the driver characteristics such as risk perception and the crash history, and those are very unique information that could be cannot be obtained from field data collection or the simulation models. So the driver type and their headway distribution in the walk zone, and may also be very helpful to identify how the driver behavior affect walk zone capacity. So this is come to the objective and the scope for this project. We try to develop time and space headway selection tables with relation to the driver type of driver, age, gender, and that especially driver risk index. And then try to study the walk zone traffic flow in different walk zone configuration, either shoulder closure or one lane closure, two lane closure, and that different walk zone configuration. So like I said, this is only a 1 year project. It's more like a test concept project. So we have a very small budget, just me and a student work on this project over last year. So the methodology here we use is first data collection and reduction. I think we spend maybe 70 or 75% of the time and effort on the data collection and the reduction. And that's very time consuming to follow every trip to get all the headway speed data from NDS data. So then after we collect all the data, we study how headway distribute, how the driver select the headway they feel comfortable when they drive through the walk zone. And then finally, we try to look the speed and the headway convert to density, how that fit in the traditional the traffic flow model. So for data collection part, we use the existing data set from the previous project. So this is a complementary data set. So we reuse previous the data collect for other project. So we found the 443 baseline events and the 256 near crash event. for each event, unfortunately, we only have like 21 second the trip length, and for critical event is about 30 seconds. So it's very short trip. But we do have a forward view videos, and that's a driver vision, what they see in the front, and also the time series data include the speed, acceleration rate, and the brake status, and the gas pedal position. So this is example the data Excel file we find for one trip, and as you can see, we got all this acceleration, pedal brake status, pedal gas position, then speed, and we have to link that Excel data with the forward view of the trip. So this is example of the driver, driver pass a walk zone. And with this from forward view video, we can see the walk zone type is how many left lane closure, right lane closure, they use combs or they use drums, what kind of traffic control device use, and how close this vehicle from the to the front vehicle. Additional data we collect include the radar data for the headway. It's basically how many seconds from the NDS vehicle and also the vehicle in front of them. And also we collect the driver risk perception questionnaire that define the driver risk index. And also we collect the data for using the highway capacity manual method. For the we collect walk zone type, is the lane closure or the shoulder closure, and then if there is a lane closure, number of lane closed, and type and the location of barriers is what type of barrier is left or is on left or is on right, and area type is a rural or urban or is a day and night, and all these are the input for the highway capacity manual walk zone capacity method. So if you have all this information, you put it in the highway capacity manual HCM walk zone capacity estimate method, you can find out what is the capacity or the Q discharge rate based on the highway capacity manual definition. For the data reduction, we only select interstate, not include the arterial with intersection or anything like that, only freeway. And from 9 different locations, include the business, industrial, and the bypass church, residential, and we look at all these variables and find only include interstate. For each trip was reviewed to ensure it was related to a walk zone. Make sure there is a walk zone, the trip pass. And also there is no merging or diverging behavior, no lane changing behavior, and the trips this missing data will removed. So we found the final data set meet all the requirement is 38 safety critical event and 64 baseline event for this study. So this table basically summarize all the data we collect, all the trips for the lane closure, 2 lane with 1 lane closed. We have a total 20 trips. And you can see we are group the trips for different level service, level service A, B, C, D, and E, and this for the critical event or baseline event. So based on the data set we have, only the shoulder closure 2-2 and 3-3 and the lane closure 2-1 had more than enough sample size. All these had more than 20 trips. So we only study those trips. The other walk zone configuration we didn't study in this project because the small sample size. So for the headway distribution, the time headway are defined as the time between 2 vehicles in seconds. And the spacing headway is a distance between 2 vehicles. driver risk perception, this is defined in the NDS before NDS study, and there is a questionnaire to measure the participants' perception of danger or unsafe driving behavior. So the score range is from 32 to 224. So the higher score indicate greater risk perceptions. So this driver is more safer driver. So their risk level is low. So we try to identify relationship between the driver risk perception and their headway selection in this study. For the traffic flow, we use the fundamental traffic flow theory, and the flow rate equal to speed times density. And if the speed density relationship is linear, and that's basically Green-Shield model can be used. So we try to fit the data we collect, use this fundamental traffic flow theory. And also we use the 6th edition highway capacity manual method to try to estimate what is the capacity based on that method. Basically, you have two different ways to measure the capacity. So this is a highway capacity manual method. Highway capacity HCM method, first you estimate what is the walk zone Q discharge rate. And that's based on all the, this is input lane closure severity index, and indicate the variables for barrier type. If it is a concrete, you put 0. If it is 1 for the columns or drums. Or the indicate factor for area type. For urban area, put 0. Rural area, put 1. Lateral distance from edge of travel lane adjacent to walk zone to barrier. And if it is 0 to 12 feet. And indicate the variable for day or night. Day is 0, night is 1. So if you put all these variable in, basically the formula is going to give you what is a walk zone Q discharge rate. Based on the Q, this is how we estimate the lane closure severity index. It's basically is how many lane open, how many lane close, and you get the index based on that formula. So after you calculate the Q discharge rate, then you can convert to the pre-breakdown flow rate. That's we define like capacity. I think that's very most important. The number we want to know. What is the pre-breakdown capacity for the walk zone? So based on that number, you probably can estimate if this walk zone is going, how long is the queue, and then other things. So this is formula you can estimate for pre-breakdown flow rate. You only need to consider percentage drop in pre-breakdown capacity walk zone due to queuing condition. And this average value is 13.4% in walk zone. That's for A. So for the results, we did study the headway distribution, include time headway, spacing headway, and we tried to look the distributions among all different driver based on the driver risk perception. And also we looked the traffic flow model for the lane closure and the shoulder closure. This is the results for the headway distribution. For time headway here, as you can see for the two walk zone configuration, 2 to 1 and the shoulder closure 2 to 2 and 3 to 3. The average time headway is about 2 point something seconds. The minimum is 0.3 to 0.47, and there's a standard deviation. That's a sample size. That's what we got from based on the NDS data we use. And also we look the time headway for different level service. We know that when the level service getting close to the capacity, and the people will like to take a less shorter headway. So we did see the headway, time headway actually decrease with the increase for the level service. So level service for the level service C is probably has the lowest time headway 2.05. If you use 2.05 headway, and you can estimate what's the flow rate is about 1756 vehicle per hour per lane. That can be considered as what is the capacity for that condition. We also look the space headway. Space headway for two different walk zone configuration and show the average 130 feet to 175 feet for the shoulder closure. And for sample size and high frequency spacing headway. So same thing for the space headway. We look at for different level service, and we also found that level service D and the E, the space headway is getting the smallest one is about average 86 feet for level service D and the E. And for the driver risk perception, this is a total distribution for NDS study driver in our sample size. So as you can see, most of the driver, the score is very high. So that means most of driver are very safe driver. They are very conservative driver. So then we look the average headway, see if there is a relationship with the average headway and the risk perception score. We see the trend when the risk perception score increase, average time headway start to increase. So that means the then more conservative the driver are there, and their headway, time headway is they like to choose larger time headway. For the spacing headway is the same. See the going up trend for the spacing headway when the perception score, risk perception score increase. And we also look the gender for the male, female. As you can see, the male, female, the time headway male actually is a little bit bigger. I don't know if that's because sample size. We have a more male than a female. But risk perception score actually show the male actually is a little bit lower than the female. For the age, for the less than 24, younger tend to select shorter time headway. For the mid-age, a little bit increase, and the senior driver will increase even more. And for the risk perception score, also show the same trend. So for the headway distribution, we look the female, male driver, and their risk level, age group, and what is the time headway average. So as you can see, with the age increase, the time headway start to increase, and then more than 60, a little bit reduce here. So same trend for the female here. So for male driver, show the average time headway actually increase all the way. Spacing headway also increase significantly with the when they getting older, seems be more conservative. Okay. So for then we look the traffic flow modeling for the lane closure 2-to-1 and the shoulder closure 2-to-2 and the 3-to-3. This figure just show the total number of 20 trips, and each trip has every 0.1 second it has one dot. You find all these points is what's the speed, what is the density. So and that you can draw a kind of the relationship between the speed and the density. We use the linear regression and show the R square is 0.57 for the length closure 2 to 1 speed and the density relationship. And also for the this is a table show the heavy capacity manual method can also used for estimate what's the this table basically include all the input for each trip. This is trip ID, level service level, and based on that, you can estimate what is the Q discharge rate based on the heavy capacity manual, and the pre-breakdown capacity here based on the heavy capacity manual. So because every trip is happened in a different location, and you see the Q discharge rate and the pre-breakdown capacity is a little bit different because all the inputs from here is different. For the shoulder closure 2 to 2, and this one based on 24 trip, and all these this point is show the speed based on the what is the speed, and during for that speed moment, what is the density around that NDS vehicle. So we use linear regression more to fit the model and show the R square is about a little below 0.5. And this one is show the 32 trip. If you see the number of trip increase, the R square is going down because that's a different location. They have a more all this point. I don't know. It's probably some something happened outline, and make these R square is going to a point a little bit below 0.4. So some discussing NDS data provide a unique opportunity to study car following model, especially you know all the information about the driver, type of driver, their age, and also in different walk zone configuration. And then we also found you can develop a speed and the density relationship for a small segment of roadway and very microscope level. So NDS data can be used to develop a car forwarding model for different congestion level. If we find the headway decrease at the level service drop, okay. So, and also we look the 85% of driver headway, time headway is between 0.8 to 2.8 seconds. As space headway is 50 to 175 feet. That's a majority the headway selection. So NDS data we found can also be used to study the headway by different driver, male driver and senior driver, and especially the risk score. So that will affect the headway selection. So some potentials for this research, we can use the results, improve and calibrate some planning level or micro simulation tools for the simulate walk zone. We know this tool QWZ, and this is the tool developed by the FHWA, and we found some formula they used were developed based on the data collected in the 1980s. For example, free flow speed and the effective length of walk zone affected by the delay, average speed in the queue, and all these kind of things may need to be updated. And I think NDS data may provide the answer for those questions. And for the Vissing model, the headway selection or distribution, in the model can be calibrate or update if we have more data to show how the different drivers select what kind of headway at walk zone. Heavy capacity menu may add the driver population factor, And then in the future, maybe some connected and automatic driving the vehicles. So right now we have advanced driver assistant technology called adaptive cruise control. Now the car manufacturer basically set up 3 choices. You have a low, medium, long distance for the headway selection. So the driver will, based on their risk level, select low, medium, or high. So based on this study, we may be able to develop some kind of model to help the vehicle automatically select headways when they go through walk zone based on their age, gender, risk level. So that make driver feel more comfortable, like they are controlling the vehicle. So those are just some potential applications for this study. For the limitations, due to the limitation of this is, like I said, complementary NDS data, small sample size, and especially the trip is very short, it's only 20-30 seconds. And a lot of risk trip is not go through entire walk zone. They just go through part of walk zone. So we didn't know how the driver headway selection change before walk zone or the taper area in the walk zone or after walk zone. So we would like to see if we can collect a longer trip and to see how that headway selection change. So this is what we propose in the second phase. We try to develop, we will plan to develop a headway selection table for different driver type and collect more data. We'll compare the headway distribution before, during, and after walk zone area. So then may be able to develop some speed flow density relationship and update the capacity estimation method, develop a method for capacity analysis, and calibrate some walk zone related planning simulation tools. So that's pretty much my presentation. I think I spent 32 minutes. We have a lot of time for question and the comments. So I'd like to open for any questions. So if you can think about any question, but I do have something like you to help before you leave. This one is please help complete this brief survey and help us plan future webinars. And this link I already copy paste to the chat box, so you can just click that link, and then there are 5 questions, very quick. It's take you less than 2 minutes to finish that this survey. So please do that before you leave. And also the last page I have is some upcoming webinar. October 23rd is about pedestrian bicycle. November 13, freeway facility reliability. And the December 4th is about some study on the Uber driver. Okay. Now I'm back to question and the comments. I can go to chat box, see if any question.
Dr. Zhou, I see one question. Did weather affect your data any?
Let me ask Dan, and she watched all the videos. Did you see any the trip for the under different weather condition, or most are clear?
There are some like raining and dark, but because of the sample size is so small, and we didn't conclude that. And but this is a really good point that we can consider in the next phase. We already request like thousands of trips, and that would be a good point to consider.
So that means we may have 1 or 2 trips during the wet pavement or the raining condition, right? Is that right?
Yes,
okay.
Correct.
Yeah, we may in the future exclude this type of trip. So I don't think when we estimate capacity, we will not to consider that trip during that condition. Yeah, impact by weather. Any other things? Any other question? I'll check the chat box again. If not, we'll close that. So let me see. I don't know how many male driver we have. Dan, do you still remember how many female driver we have? I think we have a more male driver than female driver, right?
We have that table in the page 33. The female driver, younger than 24, the number is 22, and middle age is 13, and yeah, this page.
Okay, well, yeah, female driver 22. Well, seems like we have a lot of young female driver, but male is 24. Yeah, for this middle age, actually, for the 25 to 59, only 13. More than 60 is 3. So that's a kind of small sample size for the more than 60. All right, if no other question, well, thank you all for participate. We'll perhaps see you next webinar.
Thank you, everybody, and we hope to see you at future STRIDE webinars. Thank you, Dr. Zhou.
Thank you.